Okay, for people joining this live stream, this happens to be my third live stream today. Gosh, it's almost living life in public. This is incremental language development, a variety of topics for today. We're starting off, it seems, with 2 tree-related topics. Okay, should the order of arguments for trees be data and then subtrees, or subtrees and then data?
Right. So this is important because it will determine everything else, and we are not sure. And we have shown this to, for example, Chris, and the first thing he said is, why not data first? Because it follows beta expressions with heads.
Okay, question. The leaves of the tree, are they trees or are they naked expressions?
They are also trees. You can input them as naked expressions, but they are also trees.
Okay, but the question is then, if we had, then what does it, but there's a difference between a tree with no successors and a naked expression, right? Tree, open brace, I mean, this form, well, is different from that, right?
Yeah, so the first example would be a non-terminal leaf. Like an ordinary leaf would be either data or tree of none, comma data.
Okay, well, I don't like us having, okay, why would you use tree of none, comma data? Why would you not just use data?
I think Ian is referring to a canonical form. In input,
Yes.
It can be used, but it's good to canonicalize so that we can perform operations consistently.
Is it? I mean, do we need to do that? Do we need to canonicalize the leaves, or could they just be naked expressions?
I mean, say you wanted to have options.
For the leaf?
Yep. Or you wanted to insert, like do a tree insert at a leaf. You know, it is a tree.
Well, I mean, I don't think we want the leaves of every tree to say tree of none, comma data. That seems extremely inelegant. On the other hand, we don't want every single random abstract tree to have a subtree and then to have to say none for the second argument. So we're toasted in both cases. Okay, so let's review this again. So if we have an abstract tree without any data, which will be pretty common, right? That big abstract trees will be common. Am I making sense?
Mm-hmm.
So that argues, okay, so abstract trees argues for tree of subtree, right? Okay.
Yep.
You know, data-rich trees argue for so in tree of subtree, what would the leaves of an abstract tree be?
How abstract is the tree? So there's like an abstract tree in the sense that the data is only stored in the leaves, or you can.
Well, I mean, no. If we have a K-ary tree, if we have this tree, okay, there's nothing, no data anywhere.
Exactly.
Okay, so what does that tree look like? What are its leaves like?
Like
tree of none, comma null.
Blah 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 blah.
This tree has indices, right? So each node has a number. that when we convert to the tree, we need to preserve.
Sure, but you might want a tree like this that doesn't have data.
Yeah, that I understand.
Right. But so then this tree, in the case where we are forcing, in the canonicalized form, it would be nice to be able to just have the leaves be tree of no arguments. If you insist on them having being
right.
true.
So there's three questions we have: the order of the arguments, and should subtrees be optional? Should data be optional? And also possibly should both be optional?
Right. Well, so the only reason you want subtrees to be optional is for the leaves, right? But potentially the leaves wouldn't have trees at all. See, I would argue, I don't think it makes sense to have a tree wrapper around the leaves, to require a tree wrapper around the leaves, or even to canonicalize to that. I think it's wrong. I don't think we want it.
But if there are options, if the leaf is green, we need to store it there, right?
Fine. Just like we store that in a graph with annotations. If you need to, you can make it be tree of now let's see, and this would be a subtree, so it'd be none, comma data, comma, style.
Mm-hmm.
Right.
So therefore, the pure tree, the abstract graph-like tree. I mean, look, with graphs, yeah, the abstract graph-like tree would be a pure data structure that just says tree of list of tree of blah, 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 blah. And it would just look like that. It would just be a big nested collection of tree objects. Very much like, like tree expression. Right? Tree expression and this would go hand in hand. And because, well, actually, I still think subtrees goes first. Who's arguing for it not going first?
So to me, the parallel with expressions has always been important, and the fact that now the heads will be placed last.
Why is it the head? Why is it a head?
Because we visualize the data as, I mean, if we have a tree expression, an expression tree, sorry, we will place the heads as payloads and arguments as children. And for example, that's what XML element does. And rules tree.
XML element is horrible though.
Or the input in rules tree, as Ian is writing on the left. So when we write rules tree, we say data arrow list of children. So tree will just go and flip that.
That's bad. Is there anything else that does it in the other order?
Text element.
Text element, yeah.
What does text element do? It has the subtree first.
Yeah, and then metadata.
Well, actually, at some level, who cares? Because nobody will see this. They'll just see things like this.
Yes, eventually, yeah. It's also important for us in the sense of ambiguities with relation to what happens if the data is rules. They might get confused with options.
Okay, that's a good argument.
I'll strengthen that to say that if the data is second, that it is actually impossible to have the data be a valid option to tree. So like kind of my preferred thing would be to have data be optional, like you said, because of the use case for abstract trees. but to still have data be first.
How would that work? How would you be able to distinguish? I see. So in other words, if what you see is something like tree of list tree, comma, blah, arrow, blah, then you know that there's a data missing tree
Yep.
with options.
Mm-hmm.
And actually, I mean, that case will be rare. Why would you want to style an abstract tree with no data?
A red node.
Oh, I see. I see. Yeah.
All right, tree, comma, subtrees. I mean, sorry, data, comma, subtrees. And that means the leaves of the tree can be tree of data.
No, it's an independent question. So I think what Ian is saying is that with a single argument, it's a list of children.
Oh,
Yep.
right.
Single
That
argument
makes
should be a
more
list
sense.
of children.
Right. And the other one is this. That is a leaf.
Which you don't have to type normally.
Right. Okay. I think I'm sold.
Okay. And anything else to discuss here, Ian?
Hey, this is a question. Reseating a tree. Okay. Let me just think how that's going to work.
You said reseating?
Well, I mean, if I want to make a tree of trees, that's going to be fine. It's just going to say tree of a list of subtrees. It's all good.
Yep.
Yeah, that's nice. The being able to do that without having to introduce some kind of data thingy is nice. An abstract tree of subtrees, that will be a common thing to want to do, I think.
Something else I was thinking about before, after the meeting this morning, is if the user, for example, has a collection of data and all pieces of data have been wrapped with the head tree, then how to can we have tree of bracket other trees forming the tree so that it's kind of
Well, you're a verbatim tree, is what you're saying. That the leaf is a tree expression that doesn't represent a tree. Is that what you
exactly
mean?
exactly. So we have the nodes separated because we have the pieces. It's like forming the tree by blocks. So can we form them just by application of some pieces into other pieces? So tree bracket, several trees bracket.
Tree bracket. You mean a list of trees?
So lowercase tree of bracket, lowercase tree.
Oh, a subvalue.
Right, something like that. So, I mean,
Wow.
I'm also looking for easy ways to construct trees.
Well, that's interesting. The subvalues of tree we haven't talked about.
Mm-hmm.
And whether we want accessors. I mean, I think for graph theory, our whole vertex count, vertex list, those are pretty nice. I prefer those to having accessor functions. I mean, to having, subvalues.
I think we were planning some tree children and tree data, right, Ian?
Symbols, yeah.
Yeah.
So long as tree data doesn't have some problem with, ages of oak trees and things. Never mind. It won't. Okay. Yeah, the subvalues thing I think is up for grabs. I don't know. I think we should get the thing built and then play with that.
Okay.
So my only other two questions here were, should the subtrees also be optional? Just tree open, close.
And what would that mean?
It'd be like doing tree of none, comma null.
So it's this thing here.
Yeah. It'd be a leaf with no data.
Probably. I don't think it's that important.
Mhm. Okay, we
I
can
don't
move on
know.
to the next thing then.
Yeah, I don't know about that. Ask me again after you've built it. Okay.
Mhm.
You can put it in if you want to, but I'm just not sure.
Yep.
Okay, what's next? Tree relative.
Oh, have you up? Yeah, you'll need to update documentation. Maybe look at the ref page.
This is where we get the uncle tree and things.
Yes.
I'm very excited about this tree functionality.
It's going to be useful because it sits very nicely between expressions and graphs.
Right. Okay, documentation is updated. I think we'll have a hard time understanding how we could have survived so long without this. And I think we're going to end up finding more, more uses for it in the entity framework. What was the thing I was recently? Somebody was telling me about, oh yeah, the compiler, abstract syntax trees. Okay, tree relatives. Okay, represents a position or positions or list of positions relative to a subtree of a tree. What does this even mean? Let's see the examples. No examples. Okay, so what's the question here? So this is, you see, I can imagine one day being able to say, map F, hash, comma, tree relative, parent or something. Is that obviously crazy?
But for us, tree relative is part of the part language. So this is being used as a pattern.
I don't know what it's being used as. So what you're saying that if I extract, oh, by the way, the sub-element thing, we should use the sub-element thing as an extractor for trees. Right, like if I say tree 11212, right, that should be the subtree that corresponds to that. That's where we should use the sub-values.
Seems reasonable.
And then we should probably have the elided syntax, how can you have nephews without nieces?
They should be equivalent.
Fine. Okay, but I mean, okay, so then we'd say tree 2, 3, 1 nephews.
Exactly.
Is that right?
Yep. Well, tree relative of nephews.
Well, that's what I'm not saying. Okay, hold on. Okay, why is it useful to have tree relative there? Oh, because that could be a named branch. Is that true?
Yeah, you might have collisions with keys if you're using associations.
All right, fine.
The alternative would be to force key on the keys. So one of them must be named.
No, I don't think we should do that. I don't think we should do that. I think it'd be better to have the tree relatives thing.
Mhm.
And in terms of the tree extractor language, we could say 2, 4 here, and that would give us a list out, correct?
Yep.
In fact, nephews represents a list. It's a
I
plural.
understand. That's why I'm bringing that up.
Right.
But now I have the question, if I do this, what shape of object do I get? Do I get a 2 by 3 array?
Yes.
Okay. What happens if one of those things doesn't have all of these cases?
It will be an error, like in extracts right now.
It's not a missing?
We're planning on returning a missing,
I
right?
see.
Hopefully with more information. Like if you try to extract a missing key from an association, it returns a missing.
Fine. I think that's the right thing to do.
Okay.
Ethan on our live stream says it'd be nice to support hypertrees too. What the heck is a hypertree? I should know that, shouldn't I? Let's see. A hypertree must be. I don't understand what it is, because a tree, it's like a graph has relations between two things, and a hypergraph has relations between more than two things. But a hypertree would be, I see each branch here, but it's just a partitioning of branches, isn't it? I don't think it's different. I think this is as different as with hypergraphs. I may be confused, but don't think it is.
I've never heard of the concept.
Fair enough.
Hypertree, but,
Yeah,
but we need to explore it. It does have documentation.
Okay. There's a question from Pakinji about if a tree can be predicted in some way. So that's a question of feeding this into the machine learning system. Do we have that discussed yet? How to make an encoder for trees?
We were discussing the other day about decision trees and how to train.
Right. That's good.
Yeah. So we learned about the needs of that project. And
I see. But I mean, a different issue which we should address is if you feed a tree in to, predict, for example, let's say you're trying to predict tree. Let's say you've got abstract syntax trees and you're trying to classify them. Do we know how to do that? That's the question. It's a question to be brought to the machine learning team.
Mhm.
Okay. Let's see. Kobev says it would return all nephews, but need to distinguish which order nephew, parent, etc. Oh yeah. So the issue is, okay, so there is a question of what order okay, so let's say, okay, the children of a node. So in other words, this, if I said tree relative, children, tree relative, children, that's effectively taking the tree and making it into some kind of depth first array. Is that correct?
Right now I don't know which one it is, but I think what we do already in part sets a precedent that we need to follow.
Okay.
It's the same situation you had before, this pair of lists.
Yeah, right. But I mean, I think that my point is, one of the things that this is highlighting, and I guess we don't have this, is an array tree, right? In other words, if I give you an array,
Mhm.
right, there is an implicit tree associated with that array. It's like a quad tree or something. If I was doing image processing, I could give you a I mean, even something. Well, now this expression tree would presumably make it.
Yeah.
Right? But does that work? I have to be in. Do I have to be in the prototype build?
Yeah.
I think the set of functions naturally dedicated to arrays and the set of functions naturally dedicated to trees are separate. So in arrays, we have dimensions, transpose.
Yeah, right. And I mean, in this case, it can be ragged, right? It can have a nesting down.
Exactly.
Okay, so what about data set? Data set has some kind of tree-like structure too. It'd be nice to be able to convert between data set and a tree. In fact, a data set might be a nice way to view a tree.
Mm-hmm.
Quite a nice way to view a tree, actually. Okay, so now you say, I can say here, what?
That's weird.
Well, whatever, something went wrong. Okay. Anyway, so more stuff to say here. Is there anything more to say? I mean, is there an issue here or is there not an issue here? This is basically, you're saying that part already defines its hierarchical way of having a list of these parts with a sublist of these parts.
Right. I think we first create the list corresponding to the first level, and then we go inside each of them and create a sublist for each of the children of those and continue.
Right.
From
Okay.
left to right.
All right. Anything else on trees?
Yeah, so there were some excluded notes on tree relative.
Oh gosh. Surely there's got to be a
one of the notes down there.
nibblings. Okay, well, we should support nibblings. We should support nephews, nieces, and nibblings.
Right. I think if we document all of them together, it becomes gender neutral.
Yes. Just document them on a line. Nephews, common nieces, common nibblings.
Right.
Pibblings. What is a pibbling? What is a pibbling?
The situation's worse for aunts and uncles because there's not a word that's accepted nearly to the extent that nibbling is.
That's
Pibbling
because they're an older generation and they didn't get as funky with these things.
Yeah.
Oh gosh. Well, just wait. Look, I think siblings, children, parents, siblings. I think aunts and uncles is pretty weird, frankly. And I'd be perfectly happy to call it, particularly this is tree relative, right? So I could imagine something where you say in the tree relative specification, is it equivalent to just say tree relative parent siblings? Is that possible?
That works, but siblings' children will not be equivalent because of the fact that they represent a list. Like the combined thing would just go get the what is it?
Well, the list of children, but why wouldn't this be getting? I don't understand this tree relative thing. Why couldn't you? Because look, if I would like to say, okay, so we also need the pure, common ancestor, distance to common ancestor, and then removal, whatever it is.
Yeah, cousins.
Right, but so common ancestor. So if I say tree relative -1, that gets the parent. Tree relative 1 gets the children, presumably. And then tree relative. Okay, so now how do I go up to grandparents and down to cousins? So there I would go up to grandparents and down to cousin, right? That's the cousin.
Mm-hmm.
I'm a bit confused.
That's one of the kinds of parameterizations we want is to be able to do something like that.
I think it's important to be able to do this. I think it's more important than pibblings and things. Oh, but Sander observes that pibblings must come from parental siblings. Wow, that's good. That's a good observation. Yeah. Go ahead. What were you going to say?
I just said that's why I had that as the first note.
Where?
3 types of parameterizations we made.
Oh, I wasn't reading this. I was inventing it for myself. Sorry. Number of levels. Okay. Whether to include the current branch. Okay, so how would you get
like siblings and siblings not self we have, but we don't have like nephews and also nephews not counting the children or including the children.
Okay, so this is okay. So here, tree relative -2, 2. Can I just understand what that is? That's cousins, right? First cousins. But including yourself. No, there's a standard
the
way
issue of if cousins includes your children or not.
I see. So if I went -2, 3, doesn't include my children, right? Because I went up to grandparents, then I came down the other branches of the tree, and did I go through myself or not?
Right. So do you go back down your same branch as well or not? That's a good way to put it. For some of these, we have an alternate form that excludes the branch.
Right.
But for like nephews, we just exclude the branch.
By the way, Ethan is pointing out that the function repository has a bunch of interesting tree stuff. Have we been looking at this?
Not a function repository. I'll take a look.
Need to. It's a nice one. That tree map thing is a nice one. Don't know about this. By the way, dendrograms have to map properly into trees, right? And the dendrogram way of visualizing a dendrogram of a tree should presumably visualize a tree. Well, what should that do?
I think there's a question here because dendrograms, I think the height of the branches matters.
That would have to be part of the data.
Yeah,
I think.
Okay, well, so then it's a standardized piece of the data, just like in the case of for graphs, we can have certain standardized attributes. This is useful to be able to go back and forth between dendrograms and trees.
Mm-hmm.
Okay, I want to come back to tree relative stuff, okay? So if I'm understanding correctly, and we went through this last time, in genealogy, there are standard parameters, how far you go up and how far you come down, right? Do we agree? You go back to a common ancestor, you go forwards to successors, correct?
Mm-hmm.
Okay, so now the only issue is, do you
Well, so there's a wrinkle that the second number is usually the difference in level between you and the relative. Rather
I
than
know for the removal thing, but
Mhm.
I think probably for tree relative that we should not do it that way. We should do it relative to where you got to. Okay? Because I have this feeling that I might be wrong about that this also makes sense. Does it make sense, or is that meaningless? I think if you exclude self, that's going to be different.
But in these things, for example, -2, 3, does that represent a list or a matrix?
Yeah. I think it's a list. I think if you want a matrix, use multiple tree relatives. Right? If you want a matrix, use use tree of tree relative -2 tree relative 3.
I see.
That will give you a matrix.
Okay.
Okay, I want to understand this. I'm pretty sure that this makes sense. And I think it is. Okay, so the question is, and also, how do we exclude self? Right? I don't think we should we exclude self by default?
Could be a second argument of true relative, specifically.
Oh, that's a good idea. Yeah, okay. Something which gives an information about whether to use self, whether to include self.
Mm-hmm. Or it might be a string specifying various things you might want to do. And at the moment, we just
Yeah,
have.
but what are those things? I mean, okay, my feeling is with these strings, let's throttle back on the aunts and uncles. Okay, let's not do them. We'll do children, grandparents, grandchildren, siblings, but not a lot else. Okay,
Mhm.
because I think it's. I mean, maybe we could do nibblings just for fun, but I mean, part of the reason is you're going to get very confused because human genealogy doesn't work like this. Right? The uncle, you don't usually talk about the uncle. You know, you talk about the sibling nodes, you really do not talk about the uncle nodes. And you know, it's just really confusing.
Yeah, seems good to me. I mean, we start without them and see whether
Right, but
they are needed.
Can we confirm whether this is whether I'm right that there's a different thing you get from this?
So that's a bunch of nodes from your same generation, because they all add up to 0. So that's what you're saying.
Is that supposed to be you go
No.
up to grandparent, then you go down to the great grandchildren of your grandparent, and then you look at each of their grandparents, and then you look at each of those people's children, and you get.
You have me confused. Okay, hold on. You go up to the grandparents.
Mhm.
You go down to their great grandchildren. Okay, that's what this is doing, right? At that point, you've spread out on the tree. You're now visiting all their great grandchildren. By the way, there's a case of intermediate nodes. Only the boundary, only the rim, versus the whole path. Do you understand what I'm saying? So if I say back to grandparents, there's the question of, do I include my parents in going back to the grandparents, or do I only include the boundary of the region that is the grandparents?
I see.
Right? So -2 could be, I mean, in a sense, that's the -2.
This is related to ancestors. For example, like
Yes, ancestors,
you have
right.
you have
right.
grandparent, but you don't have great grandparent and great great grandparent.
Would it make sense to treat it a bit like a level spec where an extra level of race indexing means only that level?
That's an interesting idea. I think you're going to want only that level most of the time, though.
I agree with that.
So we probably don't want to quite do it that way, but right. So you understand there's the rim and the path.
Yes.
I'm pretty sure that as you go forward, backward. Okay, so here's an interesting question. If I say tree relative 1, 1, is it the same as tree relative 2? Okay, so that's my children's children. No, I think it's by default it isn't the same, because if it's rim by default, this is my children and my grandchildren, and this is just my grandchildren. You see what I'm saying? I think, maybe, I don't know, question mark. See what I'm saying? So it's a question of whether for each of those, do I, or is this just grandchildren? I think you need to get some of these implemented. What's that?
I think you might actually want to almost do the reverse of our level specs, where if you want every generation along the way, you put everything in an extra level of brace.
Yeah, I think that might be right. And you can specify, and the justification for that would be you specify the spray of generations that you want.
Yeah.
So if I say tree relative and I want generations 2 through 4, that's what I would do. No, but then the default would be, if I say tree relative, just 4, that will be equivalent to tree relative of 1, 4. Is it 1, 4 or 0, 4?
4 is by default equivalent to 1, 4.
Well, these are not level specs.
But they feel very much like levels. So
they're
Yeah,
not
they do.
quite the same, but yes, they are similar.
It's like the non-negative ones are similar, but the negative ones are different.
and they are relative. So our level specs are always absolute.
Okay, but anyway, look, so there's some interesting things to figure out here. I also would like to point out another thing, which is I could imagine that in tree relative, yeah, here's another point. Ag. Oh, I see. No. So if you say I go back to grandchildren, grandparents. So I say tree, I've got my tree here, tree relative that, go back to grandparents, then go forward to A.
-2.
-2, thank you. and then I go forward on the A branch. So tree relative is a now. Okay, so here, let me make it even more difficult for you. What about this? Can we do that? Can we do pattern matching for branches? That would be cool.
I think
So
we discussed.
we've discussed using patterns in position specs, I think, for like tree replace part.
Okay. Yeah, well, so fine. But then in that case, we could.
I'm not. It's not clear to me how broad we want to go with that. With
I
supporting.
think it'd be nice eventually to go broader, but it doesn't need to be done on day one.
Mhm.
Okay, but this is a way of, so that would get me, so the reason that's useful is because except might be useful as a way of avoiding self somehow. I don't completely understand how yet. In other words, to go back to my...
It's the two arguments of except. We could say children except.
I don't remember the two argument form of except. I feel bad. Represents any pattern that matches P but not C. Oh, brilliant. Okay, so we'd say except -2, 0 or something. Well, no, actually, that isn't right. It would be -2. It would be -2, 2 except 0, i.e., cousins excluding self.
But the 0 is then a position?
I guess. What is, no, it's a level. Oh, shoot. No, it's a tree relative designation, right? So tree relative designation of 0 is self.
I see. Perhaps we should support the string self there. It's more readable.
Yeah, probably. I mean, yes, fair enough. Fair enough. Okay, so Meet on our live stream is saying that in Swedish you can select the grandchildren from which son or daughter. In other words, the cousin, when you say my cousin, I guess you're saying the child of my uncle, the child of uncle so-and-so. But if you want to do that, you should just use actual tree. Okay, here's a question. No, right. Yeah, right. You just go tree relative, and then you go forwards, right? You'd say tree of tree relative -2, and then you would say the actual person is Bob, and then their children. Right? That would get you their children.
Mm-hmm.
Right. Okay. All right. Anything else with this right now?
I don't think so.
Great. Wonderful. All right. Let's quickly look at Palindrome and a couple of other things here. Yes, we should have this. No reason not to. Yes, I agree. Why not? Tough luck. That's okay. Oh gosh, this is an issue. That's an issue.
So I think our general idea here is to have a dedicated second argument that specifies what you want. And so we make this function like have supporting multiple cases.
Yes, but that case of len is really important for numbers because the very common thing is digit reversal of a certain length.
Right, and now that we support B, it feels very natural to add that too.
A third argument.
Well, we were planning to have everything packed in the second, in this case,
I
being a
don't think
pair.
it's a good idea because I think it's like integer digits, right? Has, integer digits is separate arguments. I really think it has to be separate arguments. It's a little weird.
Right, because then it becomes less clear, this type.
Well, no, I think it's clear it's a type by the fact that it's got a,
I guess we would have to say additional arguments specify the type, because we may have types also for string cases.
What types for the string cases?
There may be palindromes that do different things, like considering separate words, ignore blanks. I don't know. I don't know much about this, but there are several cases of
Some
variants of
examples. If you go to the page for PalindromeQ, the source page.
Source page, okay. That's a lot of green. By the way, Ethan is making various comments about tree node and binary tree and so on. The name that we're using is just tree. It's not tree node, it's not tree element, it's just tree, because trees are self-eating. A tree eats trees. Now, that requires, by the way, some consistency fix up in the data structure project. So can you guys take responsibility for that?
Meaning
presumably, well, I think that currently the binary tree data structure has some names that are not consistent.
I see. Yeah, and there's also like AVL tree, KD, and there's just a bunch of trees.
Well, just make sure that they're consistent.
Yep.
That the meaning of different things is the same. And you also should probably check. I mean, by the way, in terms of the tree scanning orders and things, have you yet designed that? How we have functions that scan the tree?
Yeah, that'll be tree map.
Okay. But is there a traversal order?
Yes. There's a traversal order option to tree map.
How is it parameterized?
You can say post order, pre-order, or level order.
Okay. I mean, that's going to come into map one day. Map and scan are going to want that. By the way, is there a tree scan?
No.
We should think about it. Let's see. And also tree interacting with the compiler, I'm sure you're going to take care of that.
Yeah.
Right.
Writing it using the compiler.
Yeah, if you have a tree, a piece of code that involves tree, that will work with the compiler.
Right. There will be an easy way to extract the data structure directly and continue with that.
Right. That's the idea. Oh boy, what is this?
I think Ian is referring to the next to last with types of.
Oh boy, I'm sure Ed Pegg is an expert on these. It's the type of thing he would know about. Look, for goodness sake, it's not exactly that hard to program an arbitrarily complicated palindrome. Maybe we should skip this stuff. Maybe this is getting too complicated.
So it's not that we are proposing to implement all of this. It's just the idea of if we want the numeric case with B and len, how do we do it so that we don't spoil future
Right.
extensions?
Okay, so the cases that I think will matter, palindromes and biosequences are important. Okay, look, if there's going to be a palindrome with bases, it's palindrome without bases is just kind of cutesy because it's just base 10, and I don't know why anybody would care other than for number problems, for number puzzles. The case, there are algorithms where you need, it's pretty obscure. It's pretty obscure. I say we leave this for the time being. Let's not break anything. Let's make sure that we can get palindrome and biosequence to work. PalindromeQ of biosequence to work. Make sense?
But we do support B, right? In the second argument.
I'm thinking not.
No? Okay.
I mean, look, it's very bizarre what you mean by that. Unless you know the length of the number with the leading zeros, I don't know what you mean.
Mm-hmm.
I think it's pretty useless without the leading zeros. I mean, it's just amusement without the leading zeros.
Mm-hmm.
I mean, it may be worth it. I don't know. I mean, ask Ed Pegg, okay, whether he thinks it's, whether he cares without leading zeros.
Well, I mean, we can have 3 arguments for the particular case of numbers, and then for the other cases, the second argument will be a type. It's just some sort of exceptional case for numbers.
I don't know. I think we're being too complicated here. I mean, how difficult is it to say blah, blah, blah equals reverse of blah, blah, blah?
Yeah, true.
Oh, boy. Sandra is pointing out that 100 would be a palindrome if we... Oh, what a mess. No, 100 would be a palindrome if it was a 5-digit number. So 00100 would be a palindrome. Now, Cobb over here is commenting on if you have a tree of n nodes, then wouldn't any arbitrary node have n possible components associated with it, where components of various higher and lower order family and archaeology titles? Family archaeology titles. So that is a good question. How many overlapping subtrees? Right. So it's the number of. Yeah, I think it's simply parameterized by that question of how far do you go back in common ancestry, how far do you go forward, I believe. But again, this back and forth thing I do not understand. And it may be that it always collapses. Unless you're excluding selves. Does that make sense? And you see, I don't think it'll collapse if you exclude forward light cones, effectively, forward tree cones, if you understand what I'm saying. In other words, if you and your children are excluded from your nibblings, then that's going to propagate forwards, if that makes sense.
Yep.
Okay. All right, let's see. Anything else we need to look at here? There's utility functions under discussion. Okay, this is a different discussion, I think. I don't think we should.
Yeah, I think we should postpone this to another meeting.
All right. Anyway, trees look wonderful, so let's get them finished. Okay, and I think that wraps it up for now, and to be continued another time. All right, thanks, guys. Thanks to